Global warming and climate change have brought different crises to countries all over the world. Since the 2015 Paris Agreement was ratified, more than 100 countries plan to cut 50% carbon emission by 2030 and achieve carbon neutrality by 2050. Taiwan has also set the same goals. This year, the National Development Council announced the 2050 Net Zero Roadmap and strategies. Carbon reduction is one of the important goals. To reduce carbon emission, the government is actively rolling out policies. Businesses and academia also propose various solutions. Taiwan's first negative carbon demo plant has been set up by National Chung Kung University and CCU. By way of carbon capture and reuse, they can achieve net zero goals for energy and industrial use. Next, Professor Chen Zhiyo will tell us why they set up the demo plant.
We established the carbon negative demo plant as people started to notice climate change issues over the past few years. Climate abnormality is caused by high concentration of carbon dioxide. However, for any growing economy, carbon emissions will be an issue when factory chimneys emit carbon dioxide. If you don't capture it and reuse it, it will escape into the atmosphere, and the CO2 concentration will soar. We are turning CO2 into a resource, a material for carbon fixation. When you turn CO2 in the air into liquid or solid state, it won't leak into the atmosphere, and it becomes a daily necessity.
Taiwan has set net zero goals for 2050. A very important part is the negative carbon technology, CCUS. Negative carbon technology refers to carbon capture, utilization, and storage. These are solutions for CO2 emission from industrial production or burning of fossil fuel. To effectively use captured CO2, countries in Europe, as well as Australia and Japan, are actively seeking solutions. Currently, the consensus is to turn CO2 into chemical materials such as green methane or green methanol and create a valuable carbon cycle. Many countries are focusing on green methane. Green methane refers to methane synthesized from CO2 and green hydrogen. Green hydrogen is produced by water electrolyzed by renewable energy. The process has zero carbon emission. Japan aims to replace 90% of methane used in urban gas with green methane by 2050. So practical green methane technology is very important. European countries are also developing power-to-gas (P2G) technology, using excess renewable energy for water electrolysis. The green hydrogen produced is added with CO2 for reaction to produce green methane, which can be stored and transported. It's one way to use renewable energy for stable power supply, large-scale storage, and to cut emissions. In Germany, more than 50% of power supply comes from renewable energy. By 2026, an additional 1.4 billion euros will be invested for the promotion of green methane, P2G, to realize renewable energy storage and large-scale carbon reduction. The development of a net-zero industrial chain is ongoing. Whoever develops new technology and builds a viable business model will take the leading position. In Taiwan, the government launched the 5+2 Industrial Innovation Plan to develop circular economy. CCU established the first demo plant for negative emission in Taiwan, which can turn factory flue and CO2 pollution into zero-emission gas power generation and green materials for negative emission. There are 3 core technologies, including low-energy carbon capture, green hydrogen from electrolysis, and CO2 hydrogeneration catalyst. In total, there are 24 global patents.
As we know, CO2 capture is a very important global topic. General alkymine reacts quite easily, generating a substantial loss in secondary pollution. It's a process we have to deal with, and it defies the purpose of green CO2. Our lab has developed an organic salt system. It's different from alkymine as it's very stable, and salts do not produce carcinogenic substances. On the 2 sides of the film, there are opposite charges. With water electrolysis, we get hydrogen and hydroxide ion. Due to electrostatic repulsion, we can achieve optimal efficiency and selection ratio. In addition to high-purity hydrogen and oxygen, it also reduces the voltage required for water electrolysis and consequently lowers energy consumption. consumption. Most catalysts come with carriers for the metal part, and ours is made with pure metal, no carrier. We use external magnetic fields to induce crystal growth and enhance catalyst activity, so the alkylation reaction can happen in a low temperature and low pressure environment, therefore lower energy consumption. The device we have here is a magnetization device our lab will mass produce. A single batch can reach 20 kilograms. In the future, we can scale up this prototype for mass production.
NCKU's carbon-negative site converts CO2 into green methane at low temperature. It will enable Taiwan to self-produce natural gas fuel and generate power with zero carbon gas. Green ethane and propane can be dehydrogenated, then made into ethylene and propylene, raw materials for light industry. It's a substitute for the traditional light pyrolysis oil and provides a huge business opportunity for the CO2 conversion system, significantly improving the economic viability of CO2 reuse. At this stage, the carbon dioxide conversion rate has reached nearly 100%. The selection ratio of ethane and propane can reach 20%. Carbon dioxide that was previously frowned upon has now become a new means of green economy. It can be the basis for carbon recycling materials in the future and benefits development of an international green supply chain. Next, Professor Chen Zhiryo will share with us how the demo plant operates.
In fact, there are many ways to reuse CO2. For example, we all know dry ice, carbonated drinks, and soda water. They are all made with CO2. But the amount of CO2 used is limited. Tens of thousands of tons of CO2 is produced and emitted by the manufacturing sector. Therefore, it's important that we find a way to convert and remove such a large amount of CO2. We must develop methods for industry use, which consume CO2 at large scale. Fuel use will be a very efficient way. When you convert CO2 into methane or into ethane or propane, methane is a fuel. It's necessary for household gas and thermal power plants. With ethane and propane, you can further react to get ethylene and propene. Ethylene and propylene are raw materials for petrochemicals. The demand is large. How should companies get involved? There are many ways to do that. Cost is the top priority. Then it's the usage. It needs to create a great demand. As for the cost, now the cost is a bit high. But we can expect future carbon rights and taxes to go up. There will be higher costs for carbon emission. From an economic perspective, this is a brand new opportunity.
Carbon rights derived from negative emission materials can offset a company's carbon emissions or even be traded in a carbon market. NCKU has plans to cooperate with China Steel, China Petrol, and Changchuan Group to convert waste gas from China Steel and turn CO and CO2 from the steel industry into green gold. The NCKU negative carbon demo plant has completed the feeding trial and now operates officially. It's the first step towards commercialization. Next, we'll seek funding and an ideal site for expansion. The goal is to build a large-scale demo plant that meets international standards. Next, Professor Chen Zhiryo will share with us the vision of NCKU Carbon Negative Demo Plant.
ESG.
Everyone is talking about ESG these days. E, environment, is the most important. Timely actions must be taken. As to the corporations, in fact, many of them are enthusiastic. For example, TSMC. We are also commissioned by CSC and CPC for their projects. A lot of them are taking actions. As to foreign enterprises, we are talking to quite a few companies. Companies from Japan, Germany, and the US. Especially in the EU, everyone understands the demand. The Russia-Ukraine war results in an energy crisis. As a consequence, natural gas is in short supply. Think about it. If we can convert CO2 into natural gas, isn't that wonderful? As to hydrogen, we understand in the EU the proportion of renewable energy is very high. Germany or cities like Geneva rank among the top, so does Spain. They can produce hydrogen. Right now, companies in Germany are talking to us.
The key to CCUS lies in mass production of green hydrogen. The International Renewable Energy Agency has plans for South America, Europe, Africa, South Asia, and Australia to set up water electrolysis plants that use renewable energy to mass-produce green hydrogen and use CO2 as a stabilizer for hydrogen. Currently, European countries including Greece, Denmark, Norway, Belgium, and Finland, and countries like Japan, Korea, and China are all actively developing CO2 transport vessels to ship CO2 to green hydrogen production sites for synthesis of chemical ingredients such as green methane and green methanol. It's one way to commercialize green hydrogen export and helps build a global CCUS green industrial chain. This technology can even be promoted globally, turning this carbon crisis into a robust business opportunity.